Hey everybody, we're trying to find the sum of the roots or the solutions of an equation without actually calculating each individual solution or root. Now, y'all notice if you naively decide to square both sides, you would end up with some quartic expression. That is a polynomial of degree 4. It would be equal to 0, right? So theoretically, you would have an equation with one unknown, but it's fourth degree, and everybody knows that even a third degree is a pain in the ass. All right, so in other words, let's adopt another approach. Again, if you square this object, you would have x to the fourth and then a cubic term and some other terms. If you square this, you'd have a quadratic, but in the end, it would just be a quartic equal to 0, which is very difficult. There is a closed form solution that very few people even know or could do even if they knew it. All right, so let's move along. And remember, the goal is to find the sum of the roots without going to the trouble of tediously calculating all four of them. And it's not hard, but it's just tedious. There's another approach. Now, what we do right here, and this is kind of a room service equation. Notice we can factor a 3 out of each of these terms. 3 times 45, 3 times 15 is 45, and 3 times 57 is the 171 you see right here. So we can factor the 3 out on the interior of the radicand, and then by properties of radicals, you get the square root of 3. Okay, now squaring is not a bad idea, but if it turns out there's a nice way to do it that makes life very easy. If we just allow for this substitution, this dead-on obvious substitution of u equals to x squared plus 15x plus 57, see how it works out very nicely. And of course, the problem was designed to work out nicely. All right, so u is equal to x squared plus 15x plus 57. All right, and of course that becomes this object right down here. And notice this is equivalent because this expression is always going to be positive because it has a negative discriminant. X squared plus 15x plus 57 is a quadratic form with a negative discriminant, meaning it's always above the x-axis. Okay, so that's why we can do this and not worry about imaginary numbers or complex numbers. So now, so we get this result, and then squaring is just trivial, okay? And of course, right here, if you want to see the work, I doubt you need to see it, but if you factor out a u, you would end up with u times u minus 3 is equal to 0 when you bring everything to one side, okay? All right, so we have these two results here, u equals 0, u equals 3. Now let's see what we can do with that. Remember, u is equal to this object. So if u is equal to 0, we get, for the case u equals 0, we get x squared plus 15x plus 57 equals to 0. Right, it's just a trivial statement. All right. Now, if u is equal to 3, we get something similar. If u is equal to 3, and I'll do one little computation in my head here just to save the writing time here. We would have u squared plus 15x plus 57 is equal to 3, but that's the same thing as x squared plus 15x plus 54 equals to 0. Okay, so you see, as you might have anticipated, there's going to be 4 solutions. There's going to be 2 solutions to this and 2 solutions to this. Okay, but we have a nice resource at our disposal here. If you have any polynomial expression with known roots a and b, you see this is by form alone, a and b are roots of this quadratic. Okay, when you expand this out, the minus the sum of those roots is going to be the coefficient of x, right? So in this case, you're going to have, in both cases, this would be a minus 15 plus minus 15. If you want to write it that way, you can just say 15 minus 15. Or, excuse me, you can just say minus 15, which is minus 30. And y'all, that's it. It's fairly interesting because It turns out the solutions to this one are easy. The solutions right here are x is equal to minus 9 and minus 6, right? That's trivial enough, right? When you 9 times 6 is 54, right? Okay, so those two add up to 15, but right here you would get imaginary solutions owing to the fact that the discriminant is negative. And I'll write that down here. You can verify that. I'll just write this down. 15 squared minus 4 times 57 is negative, right? Because 15 squared is 225 and 4 times 57 is 228. 225 minus 228 is negative 3. All right, so you have 4 times, and I'll just say less than 0 rather than boring you with the calculation, all right? But what does that mean? When you have a negative discriminant, you're going to have imaginary solutions, but they occur in conjugate pairs and they cancel. So that's kind of interesting. Even though you don't know how nasty the complex solutions look, their imaginary parts are going to cancel just by the result that says complex conjugates occur in complex zeros occur in conjugate pairs, meaning the imaginary parts are just additive inverses. Okay, but in any event, with this we were done already right here. Okay, and this is pretty neat, y'all. This has a name. This is a special case of what they call Vieta's formulas. Guess an Italian guy who noticed this or was credited with noticing this first. I'm sure a bunch of other cultures noticed it before Vieta, but yeah, that's just how it is with names, I guess. But anyway, this is the answer. Minus 30 is the sum of the zeros without actually calculating the roots. And so right here, the sum would be minus 30. Thank you for viewing.